So now let's go ahead and work through a more calculation-heavy centripetal force practice problem. In this case, what we've got is a single electron orbiting a single proton. So essentially we're dealing with a hydrogen nucleus. Hydrogen nucleus is one proton with a single electron orbiting it and no neutrons. Now I'm going to tell you the equation for the real force that is actually causing our centripetal force in this case. In this case, the force is an electric force, and the equation for an electric force is this, kqqq over r squared. Now k is just a constant, q would be the charge of our proton, the other q would be the charge of our electron, and r is the distance between the two. And that force is the real force that's causing our centripetal force in this case. So this equation is equal to mv squared over r. Now what we're going to do is we're going to change up a few things about this problem and discuss how the force might change, how the radius might change, and how the velocity of our electron that's orbiting the proton might change as a result. So let's start off by adding another proton to our nucleus. So if we add another proton to our nucleus, we will not only double the charge, but we will double the mass of our nucleus. Now go ahead and take a second and think about what that's going to do to the value of our centripetal force. You should have answered that it will double the value of our centripetal force. And the reason why is because we have doubled our charge in the nucleus. So this Q that was representing the charge of our nucleus has increased by a factor of 2. Since all of this is equal to our centripetal force, our force must increase by a factor of 2, as long as everything else remains constant. Now let's take this one step further. Let's again assume that the radius is remaining constant, meaning that we could somehow fix the distance between our electron and our proton. And if that's the case, and we doubled the charge of our nucleus by adding an extra proton, what is that going to do to the orbiting velocity of our electron? You should have answered that our orbiting velocity would increase by a factor of 1.4, or a factor of the square root of 2. Okay, and again, this comes from our manipulating equations skill that we practiced before. So if you're not comfortable with that skill yet, make sure you go back to those videos and watch them again so that you're comfortable with how it applies in scenarios such as this. So the reason why our velocity increased by a factor of 1.4 was again because our charge increased by a factor of 2. So that's going to have our force increase by a factor of 2. And if our force doubles, then essentially what has to happen to our velocity in order for this equation to remain constant? We said that the radius was remaining fixated, the mass of the electron is remaining fixated, so we can ignore the effects of those. And then that means that our velocity squared has to increase by a factor of 2. But again, we want to know what happened to our velocity, so then we just solve for v by squaring both sides. So then you find that the velocity increased by a factor of the square root of 2, which is 1.4. So let's go ahead and change this problem even further. In this case, what we'll do is add a neutron. So what the neutron is going to do is it's going to double the mass of our nucleus, but it's not going to change the charge of our nucleus at all. So go ahead and think about that and tell me what is going to happen to the value of our centripetal force by adding this neutron here. Okay, you should have answered that our centripetal force would not change. Now the reason why is because this mass here is always referring to the mass of the object that is actually orbiting. Keep in mind this is centripetal force, so it's describing the force acting on the particle that is experiencing that force. So this mass is referring to the mass of our electron, since it is our electron that is experiencing a centripetal force about the positively charged nucleus. So although mass could influence our centripetal force, it is not the mass of our nucleus that will influence centripetal force. So even though we've doubled our mass, it will have no effect on our centripetal force. So keep using this example of centripetal force to practice your skills in this area. There are a few other things you can manipulate here, including the radius, or the distance between our electron and our proton. So go ahead and keep working on these, and if you have any questions about it, go ahead and bring them up with your individual tutor to get some personalized insights into centripetal force.